Yeah, we're live.
We can get it, okay. Our mic's not on the mic. No, it's not.
Uh-oh, hold on.
No.
Okay.
It's turned up.
It's turned up. 344. All right. Feel free to cut me off at any time.
This is live, so it's...
How many viewers do we have? Oh, 6.
Hey, look at that.
Hey.
Twice as many as last time, I think. Possibly.
Here we go. All right. I think we're on.
You ready?
You want to push the button? Yeah, let's do it.
Let's go.
Oh. Maybe show me here. No, try it.
There
we are. It's still a little bit of a learning curve for these live events.
We're getting it though.
Welcome back to Brilliant Labs Live. My name's Jacob Lingley.
And I'm Kayoe.
And we're here today to, over the next 40 minutes to an hour, depending on how much we ramble, we're going to go through how to create a interactive bulletin board using the Makeymakey.
That's kind of cool, right?
The Makeymakey as a backend and a Scratch code as the front end. This is something that we've alluded to in many public presentations that we've done.
We have, yeah.
When we're looking for an opportunity for students to think creatively, or what can a student produce that is going to represent the content that they're learning using some of the supplies in the makerspace.
Exactly.
And I often say, use a Makeymakey, create a bulletin board, even though I have never been a part of that. But conceptually in my head, it makes sense.
Of course it does, and it's one of those things where you also want to demonstrate how something like a Makeymakey, where for the most part, we know how to make banana pianos, that kind of thing.
Yeah.
How you can take something like this and actually make something a bit larger and more in-depth.
Yeah, that's right. So we're always trying to shoot for the higher order complexity projects to really challenge our students in how to use this technology in increasingly expressive ways.
Mm-hmm.
So it's interesting that we're trying to really push the gamut as far as formative assessment strategies using the makerspace and using this computational technology for higher level grade levels.
Mm-hmm.
And so today, the content really has nothing to do with the complexity of the project. This is actually a really simple project.
Yeah.
By the way, we did it in the last hour.
I think it's even less than that.
We drew the neuron design.
Oh, you did.
Well, we measured out the bulletin board, and anyway, but what we did plan ahead is we wanted to make sure that we chose a higher grade level content to really demonstrate the fact that this is a project that can indeed be done K-ish through 12. Right?
I think that's one of the important things for us too, is to focus more on those higher levels, because sometimes we don't really spend a lot of time in those upper levels, when really it's easy to transfer this kind of thing to any grade level. Right?
That's right, particularly with the amazing amount of grade 8s moving into grade 9 across the province and throughout Atlantic Canada that have a skill set going into high school. They're Scratch masters, they've used the Makeymakey, they've been exposed to the maker mindset, and how can we easily transition that? So anyway, let's actually put the content. As you can see, we're trying to take students' appreciation for grade 12 biology. There's a human physiology section and narrowing it down even more. At one point in grade 12 biology, they talk about the central nervous system, the human central nervous system. And so anyway, one of those outcomes that we saw, I'm not sure if it was SEO, whatever it was, what is the basic anatomy of a neuron? And so we can kind of imagine what students might do just to make a standard bulletin board. Maybe they would draw a diagram of the neuron and then add some labels here. The synapse, the myelin sheath, the axon, the dendrites, the soma, or the cell body, the nucleus, whatever it is that they want. So we've seen this done before. What is that next level? And perhaps the design and the concept is a stretch activity or enrichment activity. But also, how can we take that content and an opportunity to take an outcome, such as identifying the anatomy of a neuron, and take that a little further? And so here's what I think we should do today. And I'll keep it really simple. We don't have time to do So there are 4 terminals here, and we'll get to what's underneath and why these are holes and why I can stick my finger through them in a second. What I'm thinking is, because a neuron requires the transmission of an electrical impulse from one end of the axon to the other, I thought it'd be neat to take a play on how the Makeymakey, you have to hold down ground,
Right.
and then connect to the other ends.
Exactly.
You have to complete the circuit.
You're physically reenacting what happens here.
Right?
Right? Yeah.
So the idea would be, and if we had a large bulletin board, it'd be neat if you could have several students to be able to hold on to the dendrites as the ground, and then they could touch these, you know, synapse kind of axon terminals or nerve terminals and complete the circuit.
Definitely. Yeah.
For this small bulletin board, the idea is, and we did do a little, it's like a cooking show, right? You know, because we only have a certain amount of time.
We need some prep work. I think.
We've done a lot of prep work.
Yeah.
So if these are the ground, and then we can touch the conductive nerve terminal endings there, and all we're going to do today is have it list 4 different neurotransmitters, like GABA, acetylcholine, serotonin, and what was the other? Dopamine.
Dopamine.
Whatever it is, right?
And we can see that, I don't know if it shows up or not, but the conductive tape is here, here, and here, but we've left this one blank, as well as up here, you can see the ground, or the earth, is placed here, here, and here, but we wanted to add 4 of those as well to show the sort of connections through different points here in the neuron. And so our 4th one is right here, where we marked with our safety pin, or sorry, our, what is this thing?
Push pin.
Push pin.
There we go.
So then we're going to actually we're going to do that 4th one with you guys together today.
Okay, what else? Now, let's say that we get all of this done. One of the things that we didn't have time for is, this setup requires a computer, of course, right? So the Makeymakey, if you haven't used one before, this is, I shouldn't say it, but it's the biggest bang for your makerspace buck. It's an incredible invention. It was actually started out of Mitch Resnick's lab down at MIT. I say that like we have a personal relationship. I wish we would.
Cool.
If you're not following Dr. Resnick on Twitter, you should. He's behind Scratch, his team at the Lifelong Kindergarten Group at the MIT Media Lab. Anyway, Jay Silver and his teammate Matt Rosenbaum created the Makeymakey about 8 years ago, and it's recognized as soon as you plug it into your keyboard, your computer, as an external keyboard. And so the front end has a really basic set of inputs, and then the back end, which we're going to capitalize on today, has about 8 more inputs, and you can do some fancy things with the headers as well.
Right.
So when we do Makeymakey sessions, and I know you're doing one out of school on Friday, usually we just really look at the front side of the inputs. But at the high school level, you could really, actually it doesn't have to be at the high school level.
No, not at all. We can get into these extra terminals here on the back. And I think when we get into the actual building and connecting the wires for these extra connections that are left, we'll get a close-up of this through our secondary camera, and you guys can take a closer look at the actual face of this here, so you can see how it works.
Yeah, absolutely. All right. So where do we get started on this?
So why don't we code it?
Yeah, let's code it.
Okay.
Absolutely. So while you're getting the code set up, I'll kind of talk through the from concept to design to, right?
Sure.
So can you push the button? What? Can you do that again?
Okay. So I'll go back to main. Are we ready for this?
Yeah, I'm ready. Whoa!
Isn't that cool? All right.
Yeah.
Code?
Well, unfortunately, we can't see it because our name banner isn't here. Now do it.
So here's our button thing.
Wow. Lost video.
Oh, did we lose the video?
Did we lose the video? Oh, you're back. Okay.
Are we good?
We are on Wi-Fi right now, and so that may be an issue. Uh-oh. It says that the stream is good here. Total view time. All good.
Yeah?
Okay.
Are we good?
Yeah, I guess so. Let's keep going.
right.
I mean, the streaming is neat when you get into this YouTube Live, right? Because you need that encoder. So there's a separate piece of software, but it's probably because the school's Wi-Fi is having a little bit of an issue. But it says the stream status is good.
Okay.
Let's just see if we can ping another website here. Yeah, which we can. Yeah. Okay. So we're gonna keep going.
All right. All right.
Great. So yeah, the buttons are fun.
They are.
Big arcade buttons.
Yeah. Maybe we can actually show how to do this too, because believe it or not, inside of this is a Makeymakey.
We've got 8 different projects on the go in this setup. All right, while you set up the code, I'm going to go through my thought process, or arguably what student thought processes might be when they're designing a bulletin board like this. We've been collaborating with different schools who are starting out on this journey to an interactive bulletin board. What's really neat with using the Makeymakey is that it's simple construction materials that you use to create the interactivity. So when I started out, I literally just grabbed a piece of graph paper and I started to draw out, okay, I want a cell body, and I knew that I wanted the dendrites to be interactive, and then there was going to be this long axon, and that's essentially it. The great thing with a cork-based bulletin board is that you can do all the wiring for this interactive bulletin board underneath your art piece. Because we're always trying to push for as aesthetically pleasing of an end product as what our students can produce, and that way you're pulling in all kinds of different. Are you done already?
Yeah, it's an easy code.
You can pull in all kinds of different cross-curricular content. Okay, but what do you got there?
Okay. So basically, the code for this is quite simple. We have Scratch, of course. For anybody who's familiar with Scratch, has heard it referred to before as event-based coding. And for us today, we have 4 events. We have 1, 2, 3, 4 different connections that we're going to actually pair up with a sound file that Mr. Lingley is going to be kind enough to provide us with. And so, when we're coding this, that's literally all that we're focusing on, is setting up 4 separate events. And each one of those events is connected to one of the up, down, left, or right arrows.
Yeah. Can you do for those who may be joining who are completely new to Scratch, can you do your theater analogy of what's going on?
Yeah, sure, yeah, good point. So Scratch, for anybody who's new at this, is a really cool program. And we love it. The kids really latch on to it, the students, and it's easy to sort of grasp and understand the sort of process and the logic with it. And it's a nice sort of entry point for coding. Basically, to help navigate yourself through this interface, they've presented it as a theater play, right? And so, for example, whoops, I just made a cat meow, pesky cat. For example, our backdrops or our backgrounds are called the stage.
Right.
The sprites are down here. These are like our characters. We have costumes for each of those characters. So if we wanted say for example, we're making an animation, which we're not today, but Scratch has many capabilities, and one of them is to create animations in video games. Each one of our characters has different costumes, which sometimes with Scratch like that, you can see it makes him look like he's walking or running. And so a really cool setup. And the interesting thing about the actual coding side is that everything is organized into different categories. So what we pulled from today under the events category is when whatever key is pressed, right? So we've taken that event, and then we've gone into our sound category, and we've all we've done is just pulled in play sound, whatever, until done. So we don't have it sounding like it's rapping, right? And so what are the keys that you selected for this one? Yeah, so the Makeymakey, remember we were saying with the Makeymakey we have... We can actually switch to the desk camera. That's a good idea. Here, so... Scratch again. So let's go over here. I think you actually have to be in this scene, so let's do which that. Then you could just hit... There you go! Okay, so here's our Makeymakey, and this is the sort of face of it, that main sort of face. Here it is. Where am I at? Right there.
I keep changing it on you. Sorry.
So we have our Earth, which is kind of like the ground when we're talking about circuits. And for us, the Earth is all of the sort of connections we have on the top of our diagram. In the top sort of main face of this device, we have our directional arrows. We also have the space key, like your space bar. And over here on the far right, we have click, which refers to your left mouse click. And on the back, like Mr. Langley was saying, we have all of these different headers that we can then extend the capabilities of the Makeymakey even further to include other keys that are connected to the keyboard and actually connect external devices to the Makeymakey too.
Nice.
So kind of cool. So for us, right now, keeping it simple, we're just using our directional arrows to make it so that it's easy to sort of clip things onto.
Right. So that's why in the code,
Here we go.
yay! In the code, you have these scratch hats, the event hats.
Yeah.
So when up arrow is pressed, when down arrow is pressed, when right arrow is pressed, and when left arrow is pressed, or whatever that is.
Yes.
Okay,
Yeah,
great.
exactly.
So let's get into it.
Yeah, let's get into it. The next thing that we have to do for our code is actually assign sounds to this. And maybe you want to switch places and you can take over?
Sure.
Because
Why is it that my voice is going to?
Well, 'cause
all right.
yours is so
All
much
right.
more animated.
All right.
You have a more
Yeah. And
animated
speaking
voice.
of having an animated voice, we just got done today's video recording day here at Brilliant Labs headquarters. What better way to start a week? So we just shot our intro video for our next innovation challenge. So November, we partnered with Rogers Canada, and I think it's going to be pretty neat.
Yeah, it's going to be super fun.
Anyway,
Yeah.
we've been yelling I've been yelling all day. So I
We've
don't
been
think-
actually pretty good,
All
right?
right.
Yeah. But yeah, so stay tuned for that. The launch for that challenge is coming up on the 1st of November. We're going to be able to launch that.
So getting back to Scratch, one of the great capabilities here is the fact that you left coffee all
I know,
over the
look at
place. That's all right.
There you go.
One of the great things with Scratch, and students love to do this, is to record their own voice. And so what better way, to increase student ownership of a project, but to have them record their own voice. So I'm going to go into sounds here, and here is the dreaded meow. And we can easily record that. And so here are the 4 neurotransmitters that we're going to record each as separate sounds. And so record a new sound. Recording number 1, I'm going to record that as GABA.
Okay.
And now we're going to record it, GABA. And that's it. Hopefully you can see that. Yeah, you can see that. Now, this blows me away. The designers of Scratch actually have built in an audio editing function.
Yeah.
So you see this one, GABA. If you play it right now, okay, that's not too bad.
It's not. Well, let's demo it with the next one, maybe.
GABA. Well, we've got a little bit of space here, right? So
Sure.
I can highlight that and get rid of it. And so now, right? There's no break. And so, and then I trail off there, so we can get rid of that as well and come back.
There we go.
There we go,
I think
right?
that's pretty good.
Well, thank you.
Yeah.
We're far too complimentary for
Better.
this. Okay, and so let's go with a new sound. I'm not going to type it in. I'm just going to go with it. What is it? Serotonin. Serotonin. See?
Ooh, I can hear me, so let's edit me out of there.
Gone.
There we go.
KO.
We don't need me in there.
Don't need you in there.
No.
Serotonin.
Perfect.
Serotonin.
Just like you could like rap anyways, eh?
Do a DJ.
Yeah,
do
you
a
could-
do a DJ. Do a remix.
Put your DJ hat on.
All right, next one. What do we have? Dopamine. Dopamine. Okay.
So far, so good.
So far, so good. And we can get rid of all of that. The reason why we're getting rid of the trailing end of the sound will make sense in a moment. Probably 3 minutes at the rate of what we're going here. And the last one is, I got her, acetylcholine or acetylcholine.
Yeah. Well, how do they pronounce it in Dal?
Yeah, let's not go there. Yeah, it was one of those things. We're going to go with the Dalhousie University pronunciation.
Okay.
I had good times there.
Yeah.
Great times.
Acetylcholine.
Acetylcholine.
All right.
Okay, there we are. Extra points for the person who can actually find a reference to someone else saying it's acetylcholine.
Acetylcholine.
So we have our 4 sounds now, and when we go back into the scripts, we have up arrow, down arrow, right arrow, left arrow. So I should be able to step through those.
What's still coming to the cat?
Oh, sorry. Right.
I left some coding for you.
Yes, you did. So now we actually have to change it from meow. Yeah, I was in pure confusion there for a second. I had no idea what was going on.
You thought, why do you sound like a cat?
Yeah. Well. Okay.
GABA, acetylcholine, serotonin, dopamine, serotonin, GABA, dopamine.
That's a project right there.
You're switching the things too.
Oh, I'm sorry. There we are. Whoops. Okay, so I think our code is working now.
Yeah.
We know that it's working. And now what?
Now we actually test it out on here.
We need to actually map the keys to the Makeymakey, and we already have that here,
Yeah.
right? So let's make sure that our connections are all
Okay.
right. So this is the back end of what we've created, and now we need to figure out the front ends. And this is something that I talk to students and teachers quite a bit about, making sure that they think about the entire user experience. Right? So the front end, the back end, and you can go, we're only doing a simple sound enabled scratch sketch here. You could have sprites that are projected onto this, and shout out goes to Mr. Doucette's class at Riverview High School,
Yeah.
and they've got a really neat scratch-enabled interactive bulletin board that they're working on right now that has some projection involved with it as well.
Super impressive.
Yeah, so
Should we just test it out?
I think we should just test it out.
All right.
Now, do we want to remove this?
Yeah, why don't we just to show? Why don't we do?
Oh, I see. Sorry, you've already hooked this up. No, let's test it out.
Yeah. Okay.
Test it.
Here we go. Ready?
Yeah. Wow, it works really well. It would probably help. Oh,
We need to be
you were
on-
changing the camera views.
Put it on.
Okay,
scratch.
do that again.
No, put it on.
Oh,
scratch.
you want me to? Okay. There.
There we go.
Try it.
Okay, here we go.
GABA,
There's one. Now we can try different grounds or different earths with the same sound.
GABA,
Work.
GABA.
No way. Okay, and shall we hold hands?
Oh yeah, sure. I thought that was a high five.
Oh, this is so nice.
All right.
GABA, GABA,
Here, ready? Put your. Here we go.
GABA.
That works.
Anyway, so you can have a lot of fun, as you already know about the Makeymakey, but this, are we contriving a connection between the installation and the content? Maybe, but
I think for this too, it's also just a way to test content knowledge too, right?
Right.
So it's more that than the latter,
Right.
because then you're actually working with something that you've previously learned and demoing your knowledge
Right.
of how that works.
Absolutely.
And then the questions can come up: why are you high-fiving? Why are you touching like that? Why
Yeah.
doesn't it just happen? And
Yeah.
then the student can go into a description of, well, it's because of the transfer of, right?
Yeah,
And then,
absolutely. So it really quickly brings in other subject area content.
Yeah.
What I find is when teachers challenge students to create these interactive installations, students are forced to understand the content at a higher complexity level and master it so that they can create their vision of the user experience.
Right.
So they're pushing themselves to master that content first, and even if they're not consciously doing that, they're just discussing the interactivity and the possibilities between their group members.
Yeah.
You don't hear them discussing very much. They're using the proper vocabulary, and
Yes.
I'm really not describing this correctly.
well,
right now.
it's also that whole idea that it's not just regurgitating knowledge
Yeah.
from a book, you're actually applying that knowledge in a way that is your own. You're making
Yeah.
it unique. You're being expressive at the same time, right?
Absolutely.
Should we try these other ones?
Yeah, so let's try the other ones.
Dopamine.
Okay, or holding down the ground.
Dopamine. Serotonin. GABA.
That's awesome!
So they all work.
I love it, except this one.
Yeah.
And so in this one, all right, let's carefully remove this.
Okay. We can
Right.
even pull it back.
Yeah.
if we want to.
Oh, how about we pin this up and we'll just look at the wiring
Sure.
down here.
Okay. So this one.
And we'll just put it here. Does that work?
Yeah.
All right.
It's gonna stay.
The setup is really simple, and so this is where you can get pretty complex, and you're getting into different levels of interactivity. And so, in planning this out, it is important to think about how your connectors are going to be made, and then what is that top level aesthetic dimension that you want to put into it? What materials are our users going to see first?
Right.
When you're selecting conductive materials, we could have used a plethora, right, of different materials. Did you like that?
I like that word.
So, taking a trip to the local hardware store versus online shopping. So we have 3 of our favorites here. Conductive copper tape is becoming more and more common in classrooms. And so this is adhesive on one side and it's copper on the other. It is fairly expensive, actually. 2 of the 3 of these products are going to be fairly expensive, but it allows for a really nice, clean install. Also, the copper is, I don't know, is shiny. It's nice to look at, right?
You can peel it back and see the guts.
Yeah,
It's
exactly.
nice to see- yeah.
Now, it is important to note that when you're using copper tape with any circuit, it is much more conductive on the non-adhesive side than what the adhesive side is. Similarly, this is just plain old duct tape that you can buy at Home Depot, Home Hardware, anywhere. It is still expensive. I think it's around $15 for a roll like this. The great thing is, and this is what we used in this install, it's adhesive on one side and conductive on the other, more conductive than the other side. Here's the thing though. It's got this waxy covering over it that also interferes with the conductivity. And so I've seen some people and they've actually taken their fingernail and scratched it off a little bit to make it, to get to the underlying aluminum or the tin. I'm not sure what metal it's made out of, likely aluminum.
Yeah.
So, and then thirdly, so we did use this. I know, tinfoil is the really common one that you'll see most Makeymakey installations use.
And that's just a dollar store pickup, right?
Absolutely,
Same
that's
idea.
right.
And
I
then
mean,
using
you could
things like-
even create wires by rolling your tinfoil together, or taking a strip of tinfoil and using the guillotine paper cutter and making your own very thin wires and stapling it.
Do you know what's fun too is using pipe cleaners for wires too.
Yeah,
a
that's
lot of
right.
fun for
That's a good idea. How colorful would that be?
yeah.
Right?
So then you can actually, same idea with these wires, you can match colors to make sure you're connecting the right things.
And so why are we doing all this? Why are we using different materials other than the alligator clips that come with the Makeymakey? If you guys have used the Makeymakey, there are 2 limitations with the alligator clips. One, it really limits how large of an install that you can create, because the alligator clips are short. Sure, you can connect them together, but you don't have that many that come into the kit. And 2, you will always have students that take the alligator clips and fight with the insulative protectors.
Not just the adults, not just the kids, the adults.
Yeah, and the adults as well, right? I got lucky there. Oh, there, it slipped down. So we take those and we slide them down so that you can get right at the alligator pincher. Anyway, we're using very few alligator clips in this install, just directly on the Makeymakey. One of our products of choice, and you can get it super cheap these days, is regular old telephone wire. Also, network cables, Ethernet cables, are perfect for this. Those blue 50-foot long Ethernet cables, they actually have 4 double bundles of wires inside. So when you cut this down, so this is telephone cable, but the Ethernet cable, you can have a pretty complex install with using those wires.
Yeah, and that's what we did here. Each one of these individual wires, there's 4 of them in here, that comes out of this cord, was then used as individual connections here too. So super easy to kind of.
Here's another neat thing. You can keep the insulation sheet on, but in bundled wires like this, there's always, I'm not sure the name for it, but there's always a nylon tie.
Yes.
And if you pull this, if you pull that, it cuts the, it strips the wire, the bundle of wire, really easily, and you can get at it.
And you just peel it back.
Right? So that's what we did. Make sure that you have a good, sharp pair of wire cutters and wire strippers. And there are so many skills that students learn by combining these conductive materials, like how to strip a wire, which I did a terrible job at because I didn't line up the gauges. There we go. Right? So that's what we did to install, to make this Makeymakey installation. I ended up doubling up the tape here because I found it was messing up with conductivity. I taped the wire down and then I put another layer of duct tape over it just to maintain the conductivity of the wire. So on conductivity, do you have something that we can use to check it?
I do.
There you go. Thank you.
You're welcome.
The Multimeter is an awesome tool to use for many reasons. One, because it makes you look like you know what you're doing.
That's why I gave it to you, so
Right?
you feel like you know what you're
There's
doing.
only one setting that, okay, no, after a few years, I do know how to measure the voltage of the circuit, the current of the circuit, and the resistance. But the main one that you're going to use is the conductivity, or the, there's another C word here that I'm missing. Not conductivity, but the connectivity.
Yeah,
Right?
connectivity, yeah.
So, is it completing a circuit? Now, what's neat with these, the batteries are running out with, that's not what's neat about this one, the battery's running out, but anyway, most of them have a buzzer in them. And so I learned this from watching Ada Fruits, right? Lady Ada holds her multimeter like this so that you can hear, there's a little buzz, there's a really faint buzz. Do you hear it? Do you want to get in
No,
on
I
this?
Hey, look at that.
Okay.
I never knew that.
So,
That's really cool.
what I did to make sure that everything was connected is I came over here and I've got one end and I'm coming down here too, and I've got it, right? So yes, we're good, yes, we're good, yes, we're good, yes, we're good. So it really doesn't matter where we touch on this pad, it's connected. This installation, we really don't need to use a multimeter because we can troubleshoot if there's an issue, we can figure it out easily. But imagine if you have one of those huge bulletin boards that stretches across the entire side of the classroom, a multimeter is going to be very, very useful. Of course, you would have to extend the probes in order to touch, different.
Well, you can, yes, but you can test different connection points and things along the way too. The other thing along the top of our board that we hadn't mentioned yet is the little sort of buttons that we fashioned out of these paper fasteners. Again, made out of brass, conductive metal. So then we're just connecting this into our circuit by taping it to the wires using our duct tape here. So super handy. And these are really easy to use. You just basically poke it through anything like this. Anybody who's making interactive art, same idea. You can use the same type of device to just poke it through, and it makes a little tiny button that just sort of shows out the other end, and that you can use as a part of your circuit.
So let's go ahead and finish off the wire, just like in cooking shows. We've left one step not completed. And did you have?
Yeah, we've got our extra wires here. So, do you want to move here on switch plates?
Yeah, sure. These are big projects, but even when you're, describing the brass, and who knows if these are actually made out of brass or brass plated or whatever they are, right?
Yeah.
So even I would assume in upper level high school courses, you can get into different levels of resistance based on the metallic finish.
That's right.
Right?
Yeah, definitely.
Okay, so we're just going to secure that like this.
Okay. Then this requires a tiny alligator clip.
Okay. Do you need another staple over there?
Yes,
You will?
I will. So, let's get this over.
While Kayo's fashioning this up, I'm just going to do a plug for our innovation, our Halloween innovation challenge. Actually, you're just going to do it all yourself. Brilliant Labs headquarters, where we're filming this right now, is at 575 George Street in Fredericton, New Brunswick. It's George Street Middle School. Drop by anytime. But we tell you that because if you're working on a Halloween decoration or a prop, we would love it if somehow before this Friday, and I know that there's a crazy timeline on this, if you're able to get that here, this room, the Brilliant Classroom, is actually going to be transformed into a haunted lab for both physical and virtual tours. For more information on that, check out our Facebook as well as our Twitter feed, and you can book a tour, but also, if you can get your prop to us, that would be great.
Mm-hmm. All right, so just because the camera doesn't reach this far,
did you check for conductivity?
No.
All right.
I think
I trust you.
Well, that's not. I'm talking to the desk. There we go. What we did with these alligator clips, I'm not sure. Here we go. If we take the alligator clip, all of these arrows, as well as the earth and the space and click keys, have these two holes which you can easily insert the alligator clips into, and now that's secured, and this end just clips into the wire that you have coming out of the other end. So just so everybody sort of sees what we're doing without being able to actually see it from back there.
Yeah.
Okay, so I think that's in there. We have one more ground or earth. I don't know, do we want to do that?
I don't know. I think we're good, right?
Yeah.
We already have 3 earths,
Yeah.
and there are 3 grounds. You
Yeah.
can use the word interchangeably. Often, even when students are making a banana piano or a musical instrument, they're limiting themselves to 1 ground. You can have, it's not infinite grounds, but you can have as many grounds as what the install can handle,
right,
so that you have 2 people. So what's interesting with this is, okay, let's put this back down.
Yeah. We'll see if we need to make any adjustments.
Yeah.
So does that line up with the hole? Look at that.
Lines up. It's like we planned. Now, you know what I would do if I had more time? I would take some Scotch tape and just put it around here. Of course, you would lose some of the conductive pads, or I don't know, just so that students or people interacting with it wouldn't necessarily just be students. If your finger slips and rips the paper and stuff like that, just like that.
So
there was something that I was saying before that I'm sure not.
The multiple earths.
Yeah, exactly. Yeah. So you and I can interact. Oh, do it. Tap on
let's make
scratch
sure
there.
we're on scratch. Here we go.
So I can activate this one.
GABA.
Where's the one?
Oh, and we are switching camera views.
That's hilarious.
Man, okay, well it's good to know that we're actually able to use those buttons even when we're, right? So I can... Oh, wow.
We've got so many different things on one
But
computer.
we do have 2 Makeymakeys plugged into the computer. Oh, that's actually a good point. The Makeymakeys can be remapped. So there's a tool, if you just go to Makeymakey /remap, let's say that you have a bulletin board with 26 different inputs, for the entire alphabet. You can plug in more Makeymakeys. All you would have to do, so the first Makeymakey, let's say for the 13 letters, because I think there are 13 possible inputs.
Right.
And then the next one would be the other 13 inputs to do a 26, the rest of the alphabet, right? So that's essentially what we have going on. We didn't have enough time to change the inputs so that these were actually different key presses than what this is.
Okay.
So,
do we want to test the one that we did? Because we had a left arrow, right? Which was, did we actually test this one?
Yeah, this one here.
Oh, was that the one?
Yeah, I think so.
Serotonin.
I don't think so. That's
One.
the one.
Dopamine. Acetylcholine. GABA.
That's all.
That's it. That's it.
Yeah.
We've made something brilliant.
We did. Imagine that.
So when you're looking at this, for the 2 hours that we've put into this, it's not terrible. This area I'd really like to clean up because one of the when you have students and they're really excited, there's going to be a lot of wires and there's short circuits that are going to happen everywhere. Like even just this, if one alligator clip touches the other one. So On some installs, if you want to push students to learn even more skills, think about using a breadboard to clean up some of those connections.
Yeah, or even to hide those connections with, say, a 3D printed cap case or whatever.
Yeah, absolutely.
Lots of options, or even just a cardboard box.
That would be cool.
Yeah.
I think the nucleus could have been the Makeymakey inside it or something.
Ooh,
like
that would be really cool.
So an extension activity, and really we should have planned to have time for this. Oh, YouTube Live right now is just flipping through. We're running out of delay, by the way. An extension would be to use a Raspberry Pi for a headless display.
Yeah.
So we don't need a screen for this install. So if you think about that, like, what are you going to do with a computer? Because it has to be attached to the Makeymakey, right?
Yeah.
That's one of the limiting factors of what we have set up here. However, there are a couple of things that you can do. But if we have more time, I'd use a Raspberry Pi.
Yeah, definitely. Raspberry Pis come like they come with
I have
scratch
it over
and
here.
everything. So it's just a matter of doing it through that, and you're ready to go. Oh, we have one, right? And so with that, then this becomes sort of something that's more portable, and it just sort of plugs in beside on the wall, and you're ready to go, as opposed to having a laptop that's hooked up to this whole install, right? Oh, I'll get into here, I think is what. There you go.
We're gonna work on this. There we go. So if you haven't seen one before, this is a Raspberry Pi. It's a single board computing device. It's a miniature computer that you can carry around with you, and it's incredible. It's around 45 Canadian dollars. Time you get a whole setup and things like that, you're pushing around 100. But you can bring your own keyboard, your own mouse, your own monitor, and you can set it up, get it into your Scratch sketch, and you plug in your Makeymakey into one of the 4 USB ports there, and away you go.
Yeah.
Right? Then you can disconnect the keyboard, disconnect the monitor, and you would have a headless install, because you would just need the Raspberry Pi hooked up to a power source, of course, to the Makeymakey, and it's a lot cleaner. You're also challenging students to learn how to use a Raspberry Pi.
Exactly, and wouldn't it be neat to have an install there with a Raspberry Pi, so that you could challenge students to swap this board out with something new, plug your monitor and keyboard into your Raspberry Pi, create a new code that relates to your new project that you have on the go, right? And just keep swapping it out using the same setup that you had from the start, eh?
I think we should do this one more time, and that's it.
Yeah.
All right, I like it. This is fun.
Well, hang on, let's wait to make sure that we're
Should you actually open that up?
Let's see.
Sorry.
It's okay, you're just so eager.
I am eager.
Let's do high fives.
High fives.
Okay.
Acetylcholine. GABA.
And we're switching screens. This is awesome.
Serotonin.
Keeps flipping the screen. Dopamine's the
there we go. We have to get that figured out.
Yeah.
All right.
Here we go.
Well, listen, let's switch places because our name tags, there we are, and we actually have our table marks. We've got a lot of things on the go here at Brilliant Labs, and we're excited to be able to share them with all of you throughout Atlantic Canada. There's a few things that you can do to help us out. One, if you're involved in the Halloween Hacking and Animatronic Challenge, please email me, jacob@brilliantlabs.ca, to book a tour as well as getting your prop or product here. A heads up, we will be in St. John on Thursday at MyNB. If you happen to be finishing up your decoration, bring it there and we can bring it back. Another way you can help us out too is by subscribing. This is a very shameless plug. Subscribing to our YouTube channel. Since the last time that we've done one of these YouTube lives, we've actually gone up 12 subscriibers.
Ooh, that's awesome.
That's awesome.
That's pretty good by our standards.
I made that number up, we are increasing because I saw thereabouts. And the other thing is number 3, keep checking back our Brilliant Labs website, because there's some really neat projects that students are creating, that teachers are creating, and we've got to do a major uploads and put some of those projects up there. But it's an exciting year, and we're only rounding off October, so keep the interest up. And if there's a project that you'd like Mr. Stewart and I to prototype and do a YouTube live, let us know.
Definitely.
that good?
I think so, yeah. I think we're,
Not bad.
yeah.
45 minutes.
45 minutes, that's good.
All right.
Yeah.
Thank you very much, folks. Enjoy the rest of your week. Happy Monday.
We'll see you next time.
Or do we do this first?